Hello and welcome to another episode of Ken's Training. Today's training is going to be on a refrigerator that the complaint is that the internal cabinet temperature is too warm. It's basically a soda cabinet, a soda refrigerator, and the cabinet temperature, I did a checklist on that. Let me get that for you. Okay, so here's the checklist that I did. I went through the system and I did like one of my AC checklists. The only thing is that this refrigerator has not been touched since the factory, so there's no service ports, so there's no gauges on it at this time. I'm going to have to use a piercing valve or a line tap valve to access the system to put my manifold gauges on there. But the cabinet temperature is 64 degrees Fahrenheit, and I really want that to be closer to 44 degrees Fahrenheit for the cabinet temperature. The evaporator inlet was 72, the outlet was 69, only giving me a 3-degree split on the evaporator coil. On the condenser coil, I was getting 74 degree air in, 76 out for only a 2-degree split, which is basically means this system is just not working at all. I put an amp probe on there, and the unit is pulling 1 amp, and the compressor is on. And I believe what's happening here is I'm just simply low on refrigerant. So I'm going to put my manifold gauges on it and see what's going on. Now, this particular refrigerator, which I'll show you in just a second, it's the refrigerant is R134A, and I usually work on packaged AC systems with R22. So I didn't want to buy a 30 pound jug of R134A, so I just went down to Walmart and purchased, oh by the way, my system size is 9.3 ounces. Now here's a 12-ounce can of R134A from Walmart for $8, $9. And if you look on the can here, it says that it has a $10 core charge. This particular can is a resealable can. You can see because it's not completely has the tin at the top. It has like a little hole. So when you have this type of a can, you have to buy these adapters, and they're like $3. You just get them in the same section, which by the way is the automotive section. Now, I need to gain access into a system that doesn't have any Schrader valves. The factory never put them on. They created it 100% sealed. So I just purchased one of these here for like $3, just a piercing valve. Some people use the terminology a line tap valve. And the parts, okay, these are the parts that come with the bullet piercing valve. So it comes with the actual valve components right here. This is where you're going to put your manifold hoses right there. And also, put that cap on. And then it also comes with a couple of these adapters, plus an Allen wrench. Now, in order for you to determine what size pipe you're dealing with, I use this tool right here, which is just a pocket caliper. So all I do, just pretending this is copper pipe, all I do is just put that on right there, and then just go ahead and read what the size of this pipe is, because on AC pipe you're using the outside dimensions of the pipe. I determine that. I already know that my line... Okay, so anyways, on mine, my size of my pipe is 5/16 of an inch. So when you look at these little adapters, I don't know if the camera's going to be able to get in on it, but it's actually stamped in right there. Oh, hold on. Oh, I don't think the camera's going to do it, but right there it tells you that that is 5/16 of an inch with this adapter, and with this adapter it is 1/4 of an inch. It's right there. Just have to look on it. So a little hard when you're doing it this way, but anyway, so when I put mine in, I'm just going to make sure that I use the correct adapter for my size of my pipe. Now another thing that I'm going to be using potentially, I'm going to do a leak check on it, but if I can't, I got a can of Super Seal here, 1.5 tons. And then inside the Super Seal kit comes your can of Super Seal, which is, by the way, 1 ounce. I don't know if you can see that right there. So it's 1 ounce of that. It's like 9.5 ounces in my system. Comes with a hose and then a set of instructions in there as well. Alright, so anyways, I just wanted to show you the parts that I'm going to be working with. First thing I want to do is I want to get on this bullet piercing valve. So I'm going to show you the refrigerator. There's the manufacturer's name with the model number, the serial number. Okay, there's your model number. It tells you that the refrigerant is R134A with 9.2 ounces. High side pressure 345, low side 162. One phase. Okay, this is what the back of the refrigerator looks like. What I did was I hooked up this here so I could put my amp probe on there to determine what the amperage is. I just went around the neutral wire right there. And I don't know if you can hear everything. There's your condenser way over there, and the condenser fan motor. Hang on. Try to get you to see that. But the condenser fan motor is working fine. The condenser's clean. I blew that off with compressed air to clean it up really good. And there's the compressor, and it is working right now. Let me see if I can put my hand on it to see how warm it is. Hang on. It's not that warm. I mean, it's just warm. It's not hot or cool or anything. Here's your metering device over here. So I know it's a capillary tube for the metering device. And right here in front of me, this is the suction line right here, going back to the compressor. So what I'm going to do is I'm going to tap in right here, which is a fairly straight section of the copper line, suction line. I'd rather get on the straight section here coming out. So I'm going to cut this up right here and put my piercing valve right there. What I want to do is I want to put my piercing valve right here. So I'm just going to take a utility knife, cut through this insulation just so I can put that in. On my suction line. So I'm just going to cut around here, and it's already split. Okay, so right there is my copper that I'm going to tap into, and I want that sticking right out, looking right at me when I am done. So in order for me to determine this size, basically you just take your caliper, go on here, and then read it, and then mine is 5/16 of an inch, which I've got the adapter for right here. So my next step is going to be to take off these items here and pull that right off. Alright. Now one thing you want to do is you want to make sure that your needle is not being penetrated through right there, so when you put it together it doesn't break the copper seal. You want to wait till you have complete control over that and you have your manifold gauges on and everything like that. Now this adapter goes in here, and there's a little divot there, and this protrudes a little bit, so it tells you exactly how that should go right there. I'm just going to clean this copper up a little bit just so it's nice and clean. Alright, so I got a little piece of emery cloth here. I'm just going to simply go around that just to make sure it's nice and clean, so I have a good seating surface all the way around. This might be a little overkill, but I don't want to take a chance of it leaking or anything like that. I want it just to be nice and clean. So, and then I'll just wipe that down with this. It looks like on the copper, it looks like it's a little bit better over here, so I'm going to make sure when I put the valve on that it's more on this side than it is over here. The copper just physically looks better. Alright, so I've got my deal all set here, and I want that to go right there. Alright, so let me just start these screws like so. I got my adapter is in there. Alright, so let me get all three of these started. And then I'm going to cinch it up until the surfaces mate together. Alright. Yeah, perfect. Okay, so now that that is anchored onto there, I'm going to go ahead and get my manifold gauges and get those ready to be put on. My low side manifold gauge. I'm going to put that on. Okay, that's right there. Oops. Okay, that's good and tight. Now I'm going to take my Allen wrench and I'm going to drive this in all the way. That is going to pierce the copper. Now, by the way, I'm wearing eye protection while I'm doing this, and I've got some gloves on for a little bit of personal protection equipment. Okay, now I've driven that in all the way. Now I'm going to back it off exactly 2 turns. I can't go more than that, otherwise the piercing screw will just pop right out. So the directions say 2 turns. So there's a half. Okay, here's my low side gauges. Now, by the way, I still haven't purged this, so I'm just going to give it just a slight purge just to make sure that there's absolutely no air in this line. Okay, there's your slight purge. Now let's zoom in. Oh, hang on, why is that not zooming? There it is. Alright, so my pressure on the system is about 62 psi. You got to make sure that you're reading your scale properly. Make sure you know which one is psi. It tells you, whoa, all right, tells you right there that that black scale is in psi. You can see it right there. And then the green one is R22. The black one there is R12. I'm sorry, the white scale is the one that's psi. And okay, so now what I need to do is I need to get a pressure temperature chart in order to figure out what that is on an R134A system. But what I'm going to do is I'm going to go ahead and start this system up, and we're going to see what these gauges turn into. Okay, I just started the system up. There it is right there, dropping down. And let's see what that drops down to. I'm going to let that settle out. Let me get my pressure temperature chart, see what it says for R134A. It's been on just for a little bit, and it's actually dropped down into a negative. It looks like it's about a negative, we'll call it a 4-inch vacuum. 4 inches of mercury. Okay. I've got an infrared thermometer here, and I've got the suction line right here so I can get an actual. So I just open up that copper right there, take my infrared, put that on there and see what that temperature is. Hang on. I did this earlier and I was getting 65. So basically I just try to get the coldest temperature that there is here. Right now it's still trying to drop it down, but it's only 72 degrees, so obviously we're nowhere near where we want to be. Obviously we're nowhere near where we want to be on the temperature. It appears as if this unit is low on refrigerant. What I'm going to do is I'm going to go ahead and unplug the unit. So right over here is where I've got that plugged in. Hang on, let me show you. I just got it like this. You just unplug that. And let's see what happens with our pressure gauges. Alright. Alright, let that, now that pressure, if that pressure comes up right there, if I can get a decent pressure on that, I'll do a leak check with that. So while that's equalizing on the pressures, I'm going to go ahead and get my leak check stuff so I can do a leak check. I'm going to use a halogen H10 I got my selector switch over here set to R134A, and I'm going to go ahead and turn that on right here. And looking at my condenser, the back section here, I was actually getting a little something around the valve here, so I tightened up on these screws here, try to get that to seat up just a little bit better. I'm also checking, I'm also checking every little nuance that I can possibly check back here, and I got to get on the other side to get to the condenser coil. But I'm just, sniffing around. Here I am going around my brand new piercing valve just in case I can pick up anything. I was picking something up here and I tightened up on these screws again, but I think I got that sealed up. Alright, so I'm going to go ahead and pull the front cover off. Alright, here's the front cover. It was just held on there by some 1/4-inch screws. 3 of them, there's supposed to be 4, but 1 was missing. And right there is the condenser coil. Give you a little zoom in on that. I'm going to turn on my H10 and adjust my sensitivity in order to get a small tick. And I'm just searching for a leak. Alright, I didn't find anything on the condenser. I'm going to open up the evaporator now. Let's see here. There's 4 1/4-inch screws that hold it in. I took one out already. There's another one, and there's 2 more here, I believe. Okay, I was able to gain access to the condenser. To the evaporator, I'm sorry. And let's see if we find anything. I'm just going to do the same thing. Just sniffing around. Kind of like this. Certainly nothing obvious. Go up the back. Go over here. Oh, whatever. Alright, something just happened. Hang on. Well, just my luck, my halogen H10 just died on me. I don't think I was going to find anything anyway, so I'm going to put this evaporator shield back together again here. And then what I want to do is I want to pull the charge so I can weigh it, so I can see how much refrigerant is in the system. And then go ahead and weigh in a charge of 9.2 ounces. But before I weigh it in, let me pull it out to see how much refrigerant I pull out. That'll kind of give me an idea what kind of leak I'm dealing with. By the way, I should mention that before I started this project, here's the thermostat. And when I first started this project, this was on about 3 or 4. And then I went and turned it up to maximum. And the cabinet temperature is still too warm with the thermostat set at full maximum, and the compressor's on, so I don't believe this is a thermostat issue. This is strictly something going on with the refrigeration cycle. So I just want to bring that up. Okay, welcome back. So here we are, and we are getting ready to continue working on our refrigerator where it's not cooling properly. So I did before my leak detector died, I was checking that evaporator coil. The evaporator coil, I didn't find any leaks. So what I'm going to do now is I'm going to pull the charge out of this machine, and I'm going to put it in this DOT tank right here. This DOT tank is right now under a 100% perfect vacuum, and I weighed it on with my digital scale, which I've got right here, and then I wrote that down. So it's basically the tare weight of the tank, which is 28 pounds, 3.8 ounces. Now, if you remember correctly, this unit has 9.2 ounces. So I do need to purge my hoses, so I'm going to lose a little bit when I purge my hoses. But I want to see how much refrigerant I take out of this system, because I want to know how bad this so-called leak is. So, oh, and one other thing that I did is I ran this unit for a little bit, just in order to write down the pressure on the low side, because I only have one low side service valve connected, and the low side on this particular unit was operating at 10 inches of vacuum, 10 inches of mercury. So using the pressure temperature chart with R134A, what you do, let's see if you can do a zoom in here on the pressure temperature chart. This column here is pressure, this is temperature. So I go to R134A, I come down to 10 inches, which on the chart is about 9.8 inches, carry that across. That tells you that it's a negative 30 inches of degrees Fahrenheit. So it's negative 30 degrees Fahrenheit is what it's saying the temperature is on the low side. Now I took my infrared thermometer and then pointed it right at the copper pipe, and I was getting 65 degrees Fahrenheit. So we know that there's a huge disparity, which there's usually, you're not going to be at saturation right there anyways, but this particular disparity from negative 30 degrees Fahrenheit to plus 65 degrees Fahrenheit, well, that's almost a 100-degree split. I mean, that is way off the charts. So, you know, we've going under the guidelines here that we're low on refrigerant charge. We're going to pull the charge out now to determine how low. So here we go. We're going to do that right now. Okay, I'm starting off with my personal protective equipment, safety glasses. I just like to use these latex gloves. My recovery machine is right here. I use an Appion G5 Twin, which is the one that I use. And I've already got my recovery tank right here, good to go, which is under a full vacuum, and we're closed at this right here. I've already got my manifold hoses hooked up. Everything is tight. I'm closed on everything. And I'm closed here on the Appion G5 Twin. I use an inline filter that goes from the AC unit coming down. Well, this is not an AC unit, the refrigeration unit in this case. The refrigerant is going to come down here. I got an inline liquid line filter dryer heading this way, so I can clean the refrigerant if it's dirty at all before it hits my recovery machine and goes into my tank. So I'm just trying to put in an extra filter to help clean that up. Currently my hoses are not purged. So the first thing I'm going to do is I'm going to go ahead and open up the blue valve here, which I've got about, if you can see that, it's about 62 psi is on the system. So I'm going to go ahead and open that up. I'm going to go ahead and open the red. I don't have to go full, oh, not the red. I don't need the red in this case. It's actually just the blue. Sorry. So it's just the blue. Keep the red closed. Come down to here. I'm going to open up the inlet. I'm going to open up the outlet. Oh, now that's where I'm going to purge to right here. So I'm loose right here on my tank connection. And right about there, I got to purge through the machine and purge everything out. Okay, that's it. I'm going to go ahead and shut these off now. So I've purged out all the air. I'm going to go ahead and open up my red tank valve. So now I'm into the system. I can begin the recovery. The red is closed. I'm going to go ahead and open up my blue. And I'm going to go ahead and open up the outlet here. And I'm going to go ahead and open up the inlet. This is under a full vacuum, so it's just going to suck into the tank. I'm going to wait till everything equalizes until for me to put the machine on. So I'm just going to let that settle out. I can hear it bleeding through the system there. All right, sounds like it's equalized. I'm going to go to off on the inlet. I'm going to turn that on, and now I'm going to open up the inlet. Okay. Everything is open, and you can see right here what the pressure is. I'm already at 10 inches there. It's like it practically didn't suck out anything. I'm going to close that. Actually, that's still coming up. So I'm going to let this sit like this for a little while to suck out this refrigerant. So we'll go off camera for now. Okay, we're back. Okay, go ahead and zoom in on my gauge. Alright, you'll see right there that I'm about, I don't know, 25 inches of mercury. I'm going to go ahead and close off on this blue valve. And now watch that needle when it's closed. Okay, I'm completely closed on the red. You'll see that I'm maintaining about 10 inches of vacuum in the system. I'm going to shut these valves off. Oops. I'm going to shut off my recovery. I'm going to go ahead and shut the red tank valve off because we're not doing anything. So everything right now is 100% isolated. All the valves are shut off. The low, the high, the tank valve, the Appion G5 recovery machine, the valves are off on that. And I'm holding 10 inches here. So I just want to make sure that that's going to stay put and not come up on me, but I got a feeling that that is going to be it. So what I'm going to do is now I'm going to take my tank and I'm going to go ahead and pull off the hose that we used to recover the refrigerant, and I'm going to put the cap back on there because when we first tested it, our weight had that cap on there. And now we're going to show you what that is. So here is my scale. I'm going to go ahead and turn it on. Let that zero out. And that's in pounds. I'm going to change the units so it's pounds and ounces. And now I'm going to put this on here. We're going to see how much this tank weighs, because we want to know exactly how much refrigerant came out of the system. Now, when we first did the tank weight, it was 28 pounds, 3.8 ounces. Alright, so we're at 28 pounds, 7 ounces. So, let's go ahead and do the math on that. So we're at 7 now. It's 28 point, well, hold on a second, it's fluctuating on me. 28.66 actually, hold on. So it's 28 pounds, 6.6, and when I first started out, it was, hold on, 28 pounds, 3.8. Alright, so that's hold on a second. 6.6, 3.8, 5, 8, 2.8. So I've taken out 2.8 ounces out of a system that's supposed to hold 9.2 ounces. We've lost 50% of the charge. Oh, by the way, one other technical word I want to use here, and one reason why I'm going through all this trouble, is because a refrigerator uses what is referred to as a critical charge. If you remember when you were going to HVAC school, a critical charge, it's a measured amount of refrigerant. So unlike an AC system where it's got, let's just say 10 pounds, 5 pounds of refrigerant in the system, and the system's a little low on charge, and I want to add a little bit of refrigerant to that system, I can top off that system. So if I had not gone through this process, and if I had just tried to top off this system, all I would have known is that I would not want to add more than 9.2 ounces of refrigerant into the system, because that's a total system charge, as we saw on the data nameplate. So by me going through this extra step, it tells me how much refrigerant we lost. I can put this refrigerant back into the system, minus this one hose that I've got a little bit of air in this one hose. But other than outside of this one hose, all my other lines are still purged and in the proper condition where I want them to be. But before I do that, there's one other thing here that I want to do. I want to actually pull this off, and I'm going to charge my system right now with nitrogen. Now, if you remember, when we looked at the data nameplate, it told you the low side pressure. That low side pressure is 162 pounds. So I know that I can put up to 162 pounds on this entire system safely. So I'm going to go ahead and put in 150 pounds of nitrogen, and then I'm going to pull the tank off, and I'm going to see if that will hold overnight, further telling me about this leak that I have going on here. And maybe with 150 pounds on the system, if the leak was a little bit on the edge, maybe I'll actually hear something or something of this nature, or a soap bubble test will show me some soap bubbles. So, so we're going to go ahead and do that right now. Okay, we pulled off the recovery. I still have my manifold gauges in the low side on. I got my service valve service hose right here, and you can see on my nitrogen tank. Okay, nitrogen, compressed air right there, compressed gas, whatever. Bring that over. You can see here that I got a greater than 2,000 psi and nothing coming out the low side yet. I'm going to go ahead, connect that on right there, and tighten that up. And then, so I don't get any air from this hose, I'm going to purge that by cracking this yellow. Hang on, I must have tightened that so tight. There it is. So now I'm going to just twist this out a little, increasing the spring tension. I don't know if you can hear that. I got nitrogen coming out there now. So just purge that air completely out of this hose. Now I'm 100% purged there. I'm off. Actually, I can go ahead and open that up right now. Okay. Now we're going to go ahead and bring that up. So I got two gauges here. I got this gauge, and I got my gauge right there. I'll put them side by side. And I want to get 150 psi on this system. Now this one here is going to bottom out at 120. So there's 120 right there. I'm going to go up. You know what? I'll just leave it right there so I can have some type of gauge accuracy, because I don't have a high side gauge working on this particular one. I guess I could actually introduce the high side gauge on this one, because I got it capped off right here in the back. Let's see if I can do that. Well, actually I can utilize this high side gauge, because this one's going to bottom out. This is more accurate. A gauge is most accurate when it's between 10 o'clock and 2 o'clock, or in this range. Once you come down to the extremities of the gauge, you lose the accuracies. Alright, now according to my nitrogen gauge, I'm about 150 pounds. Now according to this gauge, I'm not quite at 150. I'm going to go ahead and crank this out till it actually gets to 150. Okay, I'm exactly right there at 150. I'm going to go ahead and isolate everything from the system now. So we're going to shut the blue. Actually, we came up a little bit. We're a little bit greater than 150. Hold on. And you don't need this. I'm going to relax on this and shut this tank off. Shut that. That's just going to bleed out. There we go. And then when your tank is not in use, just lay it down or whatever to get it out of your way. Okay, now, on my deal here, let's see here. I was trying to get it right at 150. It came up a little bit higher than where I was at. Okay, go ahead and zoom in on that gauge. It's showing 150, 155, 160. It actually looks like it's at 165. Let me see if I can lower this down so it matches up with that 80. I'm just going to try to bleed a small amount of nitrogen out. And let's see here. I'm going to do that coming out of here. So I'm going to just crack open this blue. Alright, it's just bleeding out very gently. I just want to bleed that down so that that red needle matches the 80, and then I'm going to stop. Oh, hold on a minute. My bad. I still have the red closed. Alright, hold up. That was a poor technique. I have to close that off. Hold on. Alright, there we go. Alright, it came down a little bit more than what I wanted to. I'm just gonna put a little bit more nitrogen back in the system. I want to get this right at the 150 mark. So here we are, we're back again. And what I'm gonna do is I've got my nitrogen hooked up. I'm going to crank this up till that red, let's see here, right there is 150 on the red right there. So what I'm going to do is I'm going to go ahead and I'll shut everything off. Shut this one off. Looks like I'm not going to get it. I can't get it as precisely as I want to get it. Let me shut the tank off and relax on that spring tension again. Bleed that out. Okay. Then take my yellow service hose and I'm going to go ahead and isolate that back here so it's blanked off on my manifold set. Just lay that down and get it out of the way. Alright, so now we're tight on everything. I'm going to go ahead and open this up so it's reading the manifold pressure and open this one up. Okay. So now I can use my high side gauge and we're back seated on both of these two valves. Now you'll see that that's exactly at 150 right there, which is exactly where that's where I wanted it to be. 150 psi is the system pressure of nitrogen right now. What I'm going to do is I'm going to leave this system like this with the hoses attached, and I'd like to monitor it over 24 hours to see how bad this thing drops down. So what I'm doing is I'm doing, in effect, a second form of a leak check to see how well this thing is going to hold pressure. Once I go and charge it with R134A, I want to know how well the system is actually going to hold that pressure in. So this is where we're at right now, and we're going to sit like this for 24 hours and we'll revisit it tomorrow. Alright, it's been over 24 hours and I'm going to show you what the gauge reading is right now so that you can see it. Okay, there it is right there. It's on the high pressure side, and if you remember correctly, that needle, hold on, that needle was at 150. Now it's looks like it's about 85. So let me tell you what I need to do. What I need to do is I need to put in something like just a Schrader valve and get rid of this piercing valve, because those things are prone to leak. So what I'm going to do is I'm going to go ahead and remove that piercing valve, and I'm going to put in something like this here, which is just a line tap valve, except I don't want this exact one. I want to get one that's got like a copper T Schrader all built in one, and it's the line I'm dealing with is 5/16, so I got to get on the supply house and try and do that. Now the reason why I want to do that is because the piercing valve is not the greatest valve in the world. They don't install them for a reason, and that is they are not the greatest valve. But it allowed me to suck out the refrigerant out of the system without it bleeding into the atmosphere. So that's the benefit of allowing you to do that. That pressure drop over a 24-hour period is absolutely no good. The system isn't going to live long. If I was to just charge it, put it back in service, 3 days later the guy would be complaining that, hey, my cabinet temperature is too warm again. So you need to take it back and fix it right. So anyways, we're not going to give this unit back until we get some good pressures that don't give us a pressure drop. So anyway, so that's where I'm at right now, and I just wanted to give you an update on my system. So I have to go to the supply house and get some parts, and then I'll show you what I bought, and then we'll go ahead and do the install, and then we'll do some more leak testing and stuff like that, and see what we can find. My halogen H10, I already dropped that off at the service shop, and they have to give me a quote to determine how much it's going to cost to fix it. Brand new, they cost like $625. So I'm going to be probably just repairing the old one. And that's it for now. I'll see you later. Okay, the last time on the last video segment I was showing you that the pressure was dropping in my Coke refrigerator, and that was completely unacceptable. Now, when I did that test, I put on a piercing valve, and I used a set of manifold gauges in order to monitor that pressure. And then over 24 hours, we saw it drop down, and I said, there's no way I can live with that. One problem is that there's two problems here. Number one, I'm dealing with a piercing valve. Piercing valves are inherently not like great valves. There's a lot of areas in which a piercing valve can leak, just the valve itself. So what I did was I purchased this package here. Go ahead and close up on the part number. And this is a 3/8 inch valve. It's an inline valve. Now I took one out of the package right here, and the reason why I chose this particular size is because the copper that I'm dealing with has an OD of 5/16 of an inch. So what I did was, and I did all the calculations with this before, but I used my caliper, and I went through on the inside of this pipe here, measured that out, and that inside diameter is slightly larger, just a hair larger than 5/16 of an inch. So once I use my a small tubing cutter in order to cut out that piercing valve, I can throw this in right there, and it should fit perfectly, and I don't need additional couplings here or anything, so it'll just fit right in to the existing 5/16 inch copper. Now of course, when I go and braze this joint in, I definitely want to remove the inline Schrader. The kit came with this tool, but I have other tools to remove it as well, but I'm just going to show you for illustration purposes here. I'm going to go ahead and pull that core out because that core has a rubber seat in it, and I don't want to do any brazing with my high temperature heat with this core, Schrader valve core installed. So, so this is the part that's actually going to get brazed just like this into my system, and if there's anything that needs to be venting, it'll be venting out here. One bad thing, or one thing that I will not be able to do, was because I only have a single point of access tap, I'm not going to have 2 points. I don't have a suction and discharge service valve, so I can't do a nitrogen purge, which is the preferred method to do whenever you're putting heat onto the copper of a refrigeration system. You're trying to prevent that flaking off on the inside. But in my particular case, because I only have a single point of access, I won't be able to do the nitrogen purge. Now, another thing that I purchased is I purchased 2 of these here, which is just a small tap, and I also purchased a couple of pressure gauges. So this is ultimately what I'm going to be achieving here, or what I've already achieved. I just used Teflon tape on that connection right there. This is a 0 to 200 psi pressure gauge. So this way, once I put this into the system, and then the Schrader valve insert is in there, and I top off with about 150 psi of nitrogen, I'm going to go ahead and pull off the nitrogen, put on my pressure gauge here, and I can go ahead and monitor that. And the only points that can possibly leak is going to be this threaded connection here and here, as opposed to a manifold gauge where you can leak here, 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 here. There's multiple leak potential points all over the place with the set of manifold gauges. So I'm going to, once I get this installed, and then I can do the same test, but I can do it with, and also I can use my soap bubbles in order to check all these connections here, just to see if I'm leaking anywhere on just these few joints right here. So it's going to be a little bit more of an accurate test than the first test that I did. So my next step with this system is going to be to go ahead and install this inline Schrader valve. And you can check out my other videos, check out my videos on my channel on how to do brazing if you don't know how to braze copper. Okay, YouTubers, this is where the piercing valve was located. I just used an Allen wrench here just to remove that. This is just before I cut it out. I'm just going to show you what the hole looks like. I'm going to zoom in. So that's what the, try to get that camera to stay in focus if I can. Anyways, that's what the hole looks like when you do the piercing valve. Now, this section here, I'm going to take this out with this hose clamp, pull this drip tube off to the side. I'm going to use my utility knife, cut this, get this insulation away when I do my heat. And basically my Schrader valve, I'm going to have it here, and I'll probably just have it just like this, sticking out like that, so it's just easy access for me. Alright, so I'm going to get ready to go ahead and put that in. Okay, so here I am here. There's my piercing hole, so I know I want to cut that out. And I just took my black Sharpie to kind of figure out exactly where I want to cut. And I'm going to cut on this joint here and on this joint right here, and then put this metal in about that far before I do my brazing. Okay, so here we are. We've got our section of copper cut out. This here is the part that I want to put in. And I took some emery cloth and I just sanded this down on this, and I also cleaned inside of here. And then I just wiped everything down with a towel just to try to get everything kind of reasonably clean. Now, when I put this in, I would like about that much copper to be sticking in the pipe. So what I'm going to do is I'm just going to make a mark here. So when I go to put that in, I know exactly how far I want it to go. And on the other side, I'm just going to go right about there. So that you can see how much copper I'm going to stick in here. It's not going to block the valve at all. It's plenty of copper sticking in there. Okay, now this 5/16 is a little bit larger than I anticipated. So I'm going to take my channel lock and I'm going to stick that in, and I'm just going to crimp down here on the end. I'll be able to fill that in with my my soldering rod, which I'm using Stay Silver 15. So I got one rod right here, so I'll be able to fill in that hole when I get to it. And I'm going to do the same thing over here. I'm going to put that where I want it to go and just clamp that down, so you can see that's kind of holding. I got a fire blanket here. And I'm going to take this fire blanket and I'm going to stick it in here, so this way I can try to protect anything that I don't want any heat on. Okay, pretty much let me just clamp that a little bit better. Okay, right there. Alright, pretty much that's my job. I'm going to throw on this here, some safety glasses, and I'm going to go ahead and light off, and we're going to go to town right now. Alright. We've already adjusted our pressures. We're doing 5 psi on the acetylene and 10 psi on the oxygen. Alright, here we go. Hard in this back section here. It's always the hardest in the very, very back. Okay, let's get the other side. Okay, so I got my inspection mirror, and I can definitely see a hole on each side on the backs. Exactly where it's the most difficult for me is like right there in the very 180 degrees from where my eyesight is. So I'm going to go ahead and touch it again, and I got to get that sealed up proper. Okay, there. Go ahead and do a zoom in here. You can see we've got our access Schrader valve done. I did a video inspection, not a video, but just a mirror inspection on the back of the joints, and this brazing joint looks perfectly good. So we're gonna cool this down with some water and some towels and get ready to charge it up with nitrogen. Okay, we have finished the brazing of our access Schrader valve. I put the Schrader valve insert back in the Schrader valve, and with nitrogen I charged the unit to 150 psi. I pulled off my manifold gauges, put in my little pressure gauge, and right now the needle is reading just over 150 psi. I've got my my big blue leak detector, brush on blue here, and I'm just taking this and I'm looking for any potential leaks. And looks like there actually is a leak here on my on my threaded connection to right here. We'll get the camera, we'll show you a different angle on that so you can see what a leak looks like. Okay, so right here you can see that the pressure gauge is reading just a little over 150 psi. So I was doing my brush on blue, and right there, I wish I could stay in focus better, but you can see that bubbling action happening right there. That's what a leak looks like. So what I'm going to do is I'm just going to take this off and clean off those threads and redo that connection. And at the same time, what I'm also doing is I'm taking the big blue and let's see, I'm dipping it here in my container, and I'm also checking my joints that I just soldered, brazed rather. This is a brazed joint. So I'm looking for the same type of bubbling action here. I'm also checking the system, the suction and discharge valves. So I'm just checking anything I can to see if there's just a leak anywhere in the system at all. But I know for a fact that I got that one right there. So I'm gonna fix that and get this one put back on here. Since there's an insert right there, it's not like I'm gonna lose my charge. So as an example, all I gotta do is pull that off, and because that insert is in there, now that charge is still in the system. So I'm just gonna go ahead and redo that connection right now. Okay, so what I've done is I redid the connection that was leaking on my gauge tap right here, and I tested it with my big blue. There's absolutely no leaks right here. But as long as I got the big blue out here and I'm outside, I mean, I'm swabbing down every little thing to try to look for any bubbles. And there's no bubbles at all. When I took the gauge off and put it back on, I lost a little bit of pressure. So what I did is I just took some blue tape and I put it around here, and right where the needle is, which is about 144 psi, I just put a black mark on that. I'm going to let that sit overnight, and I'm going to check that again tomorrow to see what that rate of leak is from now till tomorrow. And then we'll make a determination if we're going to add that stop leak material or not. Because I can't find the leak with just my big blue, and as you know, I lost my my halogen H10. That thing is in the shop getting repaired. Okay, so that's where we're at. Okay, it's the following day, and here is the pressure gauge. Let me turn that around so you can see it. So here's the pressure gauge right here, and you'll see that I'm pretty much exactly where I was yesterday. I'm right at the black line. The pressure is exactly where I was yesterday. So at this point in time, let me tell you what I'm going to do. Okay, now that I can see that overnight my pressure has not dropped in this system, by removing the piercing valve and brazing in an access Schrader valve, as well as not using a set of manifold gauges like this where you have a bunch of leak potential areas, but just using that small little fitting there and then checking that and make sure there were no leaks there. See, I know that this system, this Coke refrigerator, I know it has a leak because I pulled out, I got the chart, I got my sheet right here. I pulled out 2.8 ounces and the unit holds 9.2 ounces. But this is my first time servicing this piece of equipment. The piece of information that I don't know is the leak rate, and that is what I was trying to determine. I was trying to determine what the rate of leak was, and that is why I went through this extra process. So I don't know the leak rate on the unit, but I know that I'm holding pressure overnight. And the refrigerant that I'm going to use, which is right here, R134A, is very inexpensive. This can right here is $10. So, and this is for 12 ounces, and this is a 9.2 ounce machine. So this whole can is going to satisfy that whole machine. Now I did take out 2.8 ounces, and I did put that in a DOT tank. But I think when I go back into this system, I want to just use this virgin refrigerant, so this way I know I'm starting off with really, really good, clean virgin refrigerant, fresh. Now, one other thing is using this Super Seal. I was considering using this can of Super Seal to in order to seal up the leak in this system. This product is only as a last resort. Ideally, if I'd have found the leak with my leak detector and with my big blue, between those combinations of those two, if I'd have found the leak and identified the location and figured out what material I was dealing with, which is hopefully copper and not aluminum, then I would have made a repair and I would have fixed that leak. Now it would have been the ideal solution to this situation. But I didn't find a leak, and I'm holding pressure right here. So what I don't want to do is I don't want to just add in this can of Super Seal to this, put the refrigerant in, add the can of Super Seal, and then just leave it alone. Because this product has controversial reviews about what it's going to do to the compressor. Some people say, I would never use that because you're killing the compressor because of the properties of the chemical that's inside of this. So I only want to use that where on an as-needed basis and as an absolute last resort. I don't think I'm there yet. If I can just charge this refrigerant into this machine, this refrigerator, and I can get a service life of 5 years or even 2 years, this is not a bad deal. I'm gonna let that take place because I'm going to not put an additional chemical into the system, potentially shortening the life of that compressor. So where we stand right now is I've got a fairly leak-tight system, if not a leak-tight system. I know it's holding pressure over a 24-hour period. We're gonna blow out this nitrogen. We're gonna do a full-blown evac with our vac pump, and then once we've got our system under the proper evacuation, then we're gonna go ahead and charge in and weigh in 9.2 ounces of refrigerant. So that's where we're at right now. Okay, here we go. First thing I'm going to do is take off my gauge. I still got the Schrader in there, so I'm going to use a Schrader removal tool. Pull that out. I'll try not to lose it. Alright, luckily I still got it. Okay, so now we got our system at atmospheric pressure, and I'm going to go ahead and put the Schrader core back in, because I don't want to mess around with that once I under a vacuum or anything. I'm just going to go ahead and put that back in. Oops. Alright, so make sure I'm good and tight there. Alright, we're good. Next thing I'm going to do is I want to hook up my manifold gauges. Let me close off my valves. And okay, we're going to go ahead and get the low side port over here because that's the suction side. Okay, hang on a second. Let me just depress that. Let me go ahead and open this up here on the yellow. And I'm going to open up the blue, make sure I got no pressure in the system at all. Alright, everything's good. So I got my vacuum pump here with an appropriate oil level. And I'm going to go ahead and get on the 1/4-inch section here. Okay, so we're good and tight there. All my caps are tight, and we're on line there. Okay, so I'm going to shut off my blue. Kind of give me an idea of how well we're doing here. Okay, so we're totally moving air from inside the system. You can see right there that that needle is dropping down. So if I shut this blue off, which is the low side valve, you see how that changes, and the pump sound changes and everything, so I know I'm not moving anything. When I open this up like that, I know I'm moving the nitrogen air combination inside there. So I'm just going to let that go and get that to drop down. Okay, so here we are. Go ahead and do a zoom in on my needle, and you'll see that I'm not quite at 30, but it's practically all the way down. Now, preferably when you pull a vacuum, what you like to use is a micron gauge, but I don't have a micron gauge, so what I do is I use my ears as my senses to determine if I'm at a good vacuum level. So what I do is I shut this low side valve off of my manifold gauges to determine if I can hear a pitch difference of noise in my vacuum pump. And there is absolutely no difference at all in my vacuum pump at this time, telling me that I've evacuated and I'm under a perfect vacuum under this system. If I did have a micron gauge on here, I bet you I'd be at least at 500 microns right now, but like I said, I don't. So that's the best I can do. Now, I got my scale, my digital scale right here. I'm going to go ahead and turn that on. Let me pull off my service hose off of my vacuum pump, and I'm just going to put the vacuum pump off to the side since we are done with the vacuum pump. Alright, now I'm zeroed out there. Let me go to units, and I'm just going to weigh my can. This is my can that I want to charge with ultimately. And I'm just going to write down what the starting weight is on this. So this is 15.1. Hold on. It's kind of bouncing around. I'll call it 14.8 ounces. So the can equals 14.8 ounces. Mind you, I need 9.2 ounces out of that can and put into this machine. Now, this particular can is a modern can, and it has a self-seating top. Let me show you the two differences. Okay, so I wanted to show you the two different types of cans. Now, as an example, with this can of Super Seal, go ahead and zoom in on that cap right there. You'll see that that has a completely sealed, like aluminum on it to show that this is a never opened can of Super Seal. It's a brand new can of Super Seal. Now, when you want to use this can of Super Seal into the system, you would make sure that your needle here was turned counterclockwise, so you weren't going to break that seal. Then you would go ahead and screw this on, and then you could put this on the system or put it on your manifold gauges right here, and you could add in the can of Super Seal that way. Or actually, you'd be better off just going right into the system. I don't want to add Super Seal. I'm just showing you what you would do. Now, look at the comparison now to this can here. You'll see that this can top does not look like that one. It doesn't have a piece of like a tin or aluminum going over the face of it. It actually has a hole with the seat, and this type of a can requires an adapter. Here's the adapter right here, and this is the package that the adapter comes in for this can. You just get them right in the same section that you buy the can of refrigerant in. And the can tells you right here, if you could do a zoom in right on this, it tells you that it requires an adapter to be used with this can. So all you basically do, go ahead and zoom back, is just basically take the adapter and just screw that on. Okay, so once you screw on your adapter onto the can, then you just take your hose, your charging hose, screw that on nice and tight, make sure that that is up like that, and then when you want to get into the can, you can drive that down. Now what's happening is you have a check valve or a Schrader valve right here, so you have a little bit of air in this line right here. In order to purge that, is you just want to take a flat-bladed screwdriver and just about that much. Just enough to purge just a little bit. So now that I've got this whole thing like that, and because that's a Schrader, I have to go on the Schrader valve here because it's got to depress into this to let it to go into there. So I'm just going to go ahead and weigh that one more time with the hose and everything. That's 1 pound. So with the hose, it's 1 pound and 1.9 ounces. And I'm going to go ahead and pull off my low side, put this on. Okay. All right. That should be going into the system right now. Let me see if I can't move over my my digital scale here to get a weight on that, just like this. I don't know if that's going to be an accurate weight at all, but here it is right here. 1 pound, 9.3 ounces. But there's a little bit of tension there, so it's not exactly an accurate measurement. So we're going to see what we can do about getting this refrigerant in the system. Okay, so what I did was, when we started the job, I started with the can, the adapter, the hose. I measured everything out, and it was 17.9 ounces. I wanted to get the system 9.2 ounces. So I took 17.9, subtracted 9.2. I needed this to weigh 8.7 ounces, and you can see right here that I currently weigh 8.4 ounces. So we got the refrigerant from the can into the system. We were having a problem getting the refrigerant in the system because the can was dropping down. I used my infrared here, and it was dropping down to about it was about 60 degrees Fahrenheit, then using a pressure temperature chart of 60 degrees Fahrenheit, and then bringing that over with R134A, had a can pressure of 57 psi. Then I took my small gauge here, went on here to see what the system pressure was, and the system pressure was about 45, so that really wasn't getting the refrigerant into the can. So I just used a heat gun to warm up the can temperature to try to get that a little bit higher in order to get the pressure in the can increased. So what I did was I went ahead and just looked at my pressure chart here, and if I got the temperature of the can up to 100 psi, the internal temperature would have been 124 degrees, psi. At 100 degrees Fahrenheit, it's 124 psi, but I never got it up that high. I just got it up high enough to allow the refrigerant to flow into the system. Now let me see what pressure we got on the system right now. So right now I've got 50, 60, 70, it's about 74 psi on the system right now. So what I'm going to do is I'm just going to go ahead and cap that, and we're going to go ahead and put this back online, and we're going to see what kind of temperatures we got. Alright, so we have it plugged in. Here's our pressure gauge. I actually put it back on. Let me turn that around so you can see it. Alright, so right now it's showing at about 18 psi on the low side. And let me come over here to the front of the cabinet. When I first started, the cabinet temperature was at 72. And I currently got it at 68, and it's still dropping. I'm just going to leave that alone. I took the thermostat, which is right here. There's the thermostat right there. Originally I had it, because it wasn't cooling good, I had it maxed out all the way at the high numbers, but I brought it down to 4. So currently that's at 4. I'm just going to let that go. We'll test the thermostat in a little bit, but that's where we're at right now. Okay, so we're all done charging the refrigerant into the system. We've got R134A in there. I probably put in a little bit heavy. I think I put in a total of 10.2 ounces, and it wanted 9.2 ounces. The cabinet temperature, when I was doing some checks, I got the cabinet temperature down to 41 degrees Fahrenheit. When we first started this project, it was at 64 degrees Fahrenheit. Right now, go ahead and zoom in, and you can see that I've got a cabinet temperature of 45 degrees. So I took the thermostat, which was set up at the highest level, which is 9, and I lowered that down to 4 or 5. And I'm just going to monitor this for a few days just to see how it cycles and what type of cabinet temperature we're going to maintain. Then once I establish the thermostat setting with that refrigerant charge in there, I can mount the light and then put this refrigerator back in service. And then I've got it documented. I did a full-blown checklist on this, writing down today's date. So this way, if I get another service call, I can determine what's happening with this refrigerant, because then I can pull it out and see how much refrigerant I took out of the system, weigh that out, and then have an idea of what my leak rate is. And what's going on there. So anyways, that's pretty much the video. I hope you enjoyed watching, and we'll see you later. Okay, I'm wrapping up this Coke machine job right now. The unit's been running for a few hours. The compressor has been cycling off and on, satisfying the thermostat. It's been maintaining a temperature of 41 degrees, and I'm ready to put this into service tomorrow. I'll show you the inside of the cabinet right now. Alright, so there is your interior thermometer there. You can see I'm reaching a cabinet temperature of 41 degrees. Open up the door. I've got the setting here set at 5. So it's doing just fine on that. So basically all I have to do is just mount this cover which blocks the thermostat, and then just mount this light fixture here, and this unit's ready to put sodas in it. So that's it. Okay, so that wraps up this video. I hope you enjoyed watching the video, and please, if you would like to check out some more videos from my channel, it's on Ken Training on YouTube, and thank you for watching.